So our delta H reaction is always for the reaction as written. Sometimes we need to manipulate those reactions to tell us what we need to use. So we have a series of relationships for the delta H reaction. It is similar to what you might remember from manipulating an equation and how that changes the equilibrium constant, but my manipulation rules are a little bit different. So the first is that if a chemical reaction is multiplied by a factor, multiply delta H reaction by the same factor. So for example, if reaction A is C plus 2D making E, and reaction A has some delta H reaction, for reaction B, which is 2C plus 4D making 2E, so I've taken my original reaction, multiplied it by 2, the delta H reaction for reaction B will be 2 times delta H reaction for reaction A. The second manipulation is that we might need to reverse a reaction. So we may have information going from what is listed as the reactants to what is listed as the products, but we really want to think about it going the other way. So we flip our reaction, and if we do so, the sign changes. So same original reaction, C plus 2D turning into E. If I make that E turning into C plus 2D, delta H reaction B is the opposite of delta H reaction A. Then if you can add reactions together, then you can also add together their delta H's. So this, I'm going to explicitly read it. So if a chemical reaction can be expressed as a series of steps, delta H reaction overall is the sum of the delta H for each step. This is known as Hess's law. So we will use Hess's law for a lot of stuff when it comes to finding delta H values. And the reason that all of these work, by the way, is because it's a state function. It doesn't matter if I do 10 different reactions to turn into the one that I'm interested in, because how I get there doesn't matter, just where I start and where I end up. So I do have an example here. If I have A plus 2B turning into C, that has a delta H1, and C turning into D, that has a delta H2. When I add these together, I get A plus 2B turning into D, and the delta H of this reaction is the sum of delta H1 and delta H2. Now you will probably almost 100% of the time have to do multiple of these steps in order to get the resulting reaction that you would like. So if you have to do multiple manipulations, just keep track of them so that you can do the same manipulations to your delta H before you add them at the end.